Okay, so here we have our topography lines. Um, like I said before, it's all part of this one block for some reason. So it's also including the lot boundary lines, which is kind of weird. So in order to take care of that, we're just going to type explode. So now we've just got our topography lines separate. We could probably even for now take these elevation lines and just hide them. Maybe we want to keep them for later, so that's why we don't want to actually delete anything. If you ever want to bring something back that you've hidden, don't type unhide, that doesn't do it, but type show. So there's those lines, so just remember that. Oops. Okay, so there's a couple ways in which we can turn this into topography. If we look at the top view of this too, we can see that we're only really dealing with the topography lines in these three lot boundaries. This is showing the topography for a lot of this, so you could even start to remove some of this other stuff just so it doesn't affect your site, or you can decide to treat it all if you want to go that extra mile and be like, hey, look at how we can redesign all these lots, right? But that's up to you. So, but like I said, there's a couple different ways in which we can create a surface. We can do it through Rhino. We can do it through Grasshopper. So for this, I'll show you, which I think is going to get you a higher resolution. I'm actually going to bring this into Grasshopper. So again, I'm selecting all these topography lines. And so I'm referencing a curve. So I'll go here, select the curve. So usually if there's nothing in it, it turns orange. So if I want to reference those, I'll right click, set multiple curves. So make sure you don't actually select one curve, else it will just bring in one. So I'll bring in multiple. And usually it turns green if it's selected. If it's not selected, it's just this reddish tone. So from here, this is where I can start to begin to create a surface out of it. And I can go ahead and select these again and say hide. So now I just have these curves. I can't even select it anymore. So I don't have to worry about physically disrupting this topography now. So, like I said, there's a couple ways you could do this. One way that would probably yield some really terrible results if you were to just loft these curves together probably would be really crazy because then you have to make sure they're all in the correct order, correct sequence. But like I mentioned before in the presentation, is that if you were to think about a lot of the geometry in Rhino and Grasshopper, everything can usually be generated from points. So from here, this is where I want to, instead of looking at the topography as a series of lines, I'm going to look at it as a point cloud. So again, this is where we can start to understand how this whole layout is working out. So I'm analyzing this curve. So I'm going to go to the curve tab, analyze it, or divide, or go to this division. The one I want to use is divide by distance. So in this case, I can actually determine a proximity of points off of its distance from each other. So if I were to divide it, it's just going to give the really long curves and the really short curves the same amount of points, which is going to distort it. But if I say that I want to point every X number of feet, then it'll keep it nice and uniform. So I'll go ahead and click it into there. I think it doesn't even have a distance associated. So again, this is where you can control the fidelity or the accuracy of your topography model. The more points, the more accurate it's going to be. It's also going to create a heavier file, so you kind of have to weigh the pros and cons of it. An easy way to create a slider, instead of having to go to parameters and select the slider, if I just hit a number, in this case, if I do 2, that's going to create a number slider between 0 and 10. If I want to create a very specific range within my slider, I could do something like 1 less than 50 to create a slider to be anywhere between 1 and 50. I could even do something where I say I want 1, or I could do 0.25 less than 3 and less than 15. So if I do it like that, now I'm giving my slider 2 decimal points because I have 0.25. I've added 3, which means the slider is going to start at 3, and then the highest range is going to be at 15. So now you can see that way, like instead of having to like pull this parameter and having to edit it this way, you can just double click your screen and customize it a little bit quicker. So in this case, yeah, I'm going to drag it down to something like 2. This is going to take a minute. And there you can see just how detailed this topography has become. I think that's pretty manageable. This doesn't look too crazy. So now I have a grid of points, or a point cloud for my topography. Let me go ahead and turn that off. And from here, instead of creating a surface, I'm actually going to create a mesh. And so I'm going to go to my mesh tab, and I'm going to use this triangulation tab, and I'm going to use the Delaney mesh. So I'll click here. This essentially creates a triangulated surface or geometry, but because it's such at a very high detail, you won't really see the triangulation that bad. So here's something too where you have to remember, because this will affect it. So this is an example of what I was talking about with branching. So like I said, each one of these curves are their own separate branch, and then they've got points associated with each branch. So in this case, you can see that there's even this dashed line. I want to flatten this because I want them to all be grouped into the same pool. So make sure to flatten this point by right-clicking it. It's going to take a minute because, again, there's a lot of points. But if I were, this is an example, if I were not to flatten that, it would essentially just try to create a mesh for each contour line as individual meshes. In this case, it's going to treat all these points for one large mesh. And you can see it creates it pretty quickly. And it's also going to create some overlap or some areas in these gaps, which is okay because we can always trim that away later. All right, so I can start to see just what that mesh begins to look like. If you want to actually start to see what it looks like in Rhino, you can always right-click, hit bake. Another good way to do it, as kind of a shortcut, if you hit spacebar, you get a couple different prompts, and you can just bake it that way. Now you can actually see what that mesh looks like, see if it's got enough detail to it. So it's still kind of a little triangulated. It's not the greatest, but that's one way to do it. Another way to create that surface is to actually go to the surface one, go to freeform and choose patch. So this gives you some control to figure out where, if you want to use the curve. So in this case, I don't even have to divide it, or I could use these points, again, kind of retain the detail. So let's try and do it with a point. So in this case, again, the patch usually goes way beyond the boundaries of the geometry you're referencing, but you can see that maybe it's a little bit smoother. But it definitely, in this case, the way it's defaulted, it's smoother, but it definitely doesn't have the same amount of resolution or detail to it. But I can always control that too. You can see that you have span, so let me just undo that real quick. So when I select this, you can kind of see the span is set to 20, so that means there's 20 spans in all directions. So that's what's controlling the detail here. If I want to have it to be more detailed, I have to increase my span. So let's try 50. Hopefully that doesn't destroy this, but you'll see that it's going to be much more detailed. Oh, that wasn't bad at all. So I'll show you what that looks like now. So it's hopefully at a higher resolution, but now you can see that this grid is much tighter, right? So this kind of wider spans, this one's a little bit more detailed. You can see that it definitely, if the shadow wasn't in the way. Right, so you can see how the topography is a little bit better. So let's turn it up a notch. It treated at 50 pretty easily. Let's just go to 100. Live life dangerously. Yeah, I have like a whole grasshopper board. The YouTube channel also has a lot of these recordings too. Oh, looks like it's finally there. All right, so let's see what that looks like in comparison. Oh, that's crazy. It's much heavier though, but I think that's pretty good. I like that. We could always go for it. But like I said, so this really kind of gives you a good comparison. Like some cases, you might want to have a lower resolution to it versus others. You can have, you might want to see more detail. So especially when we begin to inventory the topography, we probably want a pretty high resolution. When it comes to the drainage scripts, you might want something a little bit less detailed because it's really about just finding the general patterns. The more precise that topography is, it could really start to mess up the drainage lines because they're going to follow the 3D model, not necessarily what's actually there. So they might get like caught up in a little like crevice. So this is again kind of one of those things where you have to understand the fidelity of the data as well. So let's just go ahead and hide these. That's awesome. So is there really any, is there some range you're supposed to be doing? Or? Like I said, it depends on what you're analyzing. So like if I'm really wanting to understand an inventory and then eventually analyze the topography, then I probably want it at a pretty high resolution. So from this, we can, it's actually easy to convert a surface into a mesh as well. Versus the opposite, it's a little bit more of a pain to convert a mesh into a surface, but this is where we can start to actually analyze or start to inventory this a little bit better. So this is, again, just the Rhino. It doesn't look that great in Grasshopper because it's just a reference visual. If you want to ever change the quality, you can always go to this preview button and change it to a higher quality. But it's harder to see just because it's a surface. So I'm going to stick with low quality. Okay, so now, like I said, we can begin to inventory. So what were some of the things you guys mentioned for inventorying for a surface? So elevation, so let's start there. So it's more than just the topography lines, but we can actually start to create a colored height field. Have you guys done that before in Rhino? Okay. Have you guys done slopes? No? Okay. So these are pretty simple to do. So we'll stick with this patch for now. So essentially the way you want to create a colored height field and using a surface is, again, we're going to analyze their elevation of points. So we're going to take this surface, we're going to stick with analyze, and we're going to, actually, it's, for some reason it's over in the utilities, but we're going to divide the surface. So I'll grab this into here. You could also, you could do it this way to kind of control where those are, or you can analyze the surface itself. So looking at its surface points, so you'll see there is a difference. So this is how many points are actually constructing this. this is the points you can kind of determine. So because we already put in that much effort into a high detailed topography, we might as well use those surface points instead of controlling it. So let's look at that. So like you can see, there's 100 points going in every direction, the X and Y direction, generating over 10,000 points. So probably a pretty detailed analysis of that. So from here, you can always think of this kind of process of constructing, deconstructing, reconstructing information. So that's what we're doing. We've created the geometry, we've deconstructed it into a point of clouds, and now we're going to reconstruct it as a surface. So there's two different ways we could approach it. So in order to do it for a surface, this is where it's a little, let's do it as a mesh actually. Yeah, because you can actually bake it with the colors. So I recommend, we do it as the mesh itself. So I'm just going to go ahead and delete that. So I'll go to mesh, and then if I go to utilities, I can do mesh brep. So this creates any type of surface into a mesh, which we aren't going to lose any of the quality to it, which is great, but it's easier to show as a height field. So from here, like I could have probably even done it with this or in that area as well, but again, it's already at a pretty high quality. So from here, I'm going to do a similar thing where I'm actually going to go to analysis and then do deconstruct mesh. So this is going to create a lot of information. It's giving me, again, my point clouds. It's even looking at the faces, the colors. But what I'm really interested in these points, so the vertices in this case, this is how they define points in meshes as vertices. So from this, I can then deconstruct these points. So I may go to my vector. So again, I'm looking at the point, so that's why I'm going to this section. Choose the point, deconstruct. And the reason I want to deconstruct these is because now I can get their Z value or their elevation. And this is what I use to create the height field. So I'm going to figure out a color range for my mesh. So I've got the Z's, so this is where we go to our parameters, input, and I'm going to use a color gradient. It defaults to this color. If you want to change it, you can just right click, go to the presets, and choose something like this. So maybe it's something more of like this kind of traditional green to red. You can use this other green gradient, or you can even create your own. Let's stick with something like this. So it's asking for three different things. The bottom one is just all the different point elevations. So I'm going to drag the Z into here. So in order for it to understand this different range of colors for their elevation, I need to know what the lowest point is and what the highest point is. So this is in the case where I'm going to go to math, domain, min and max, so the bounds. So now this is going to give me, if I hover over this, its lowest point and its highest point. So in this case, because it's just like floating in the air, they might actually be in their respective elevations. That's why they're at that point. So that's what's nice too. So I've got their highest and low point. But I see that this is just giving me one output. This needs two inputs. So I need to deconstruct this domain. So now I've got them separated. So there's the low point, there's the high point. So I can just drag these into there, into their respective. So this lower limit is going to be the lowest elevation, which makes sense. And then this other end domain is going to be the high point. You can always like reverse these if you want it to be a different color range. But for now, this is okay. So now I've got colors associated with every elevation. So now I want to reconstruct this mesh. So I'll go to Mesh, Primitive, Construct Mesh. And what's nice, I can literally just pull in the same information. So where I deconstructed it, I'm just going to connect the same outputs to the inputs. So the V goes with the V, the F goes with the F. And in this case, it had colors that weren't really associated with it, but that's where I use the colors of my gradients. And let's turn this off so it doesn't look like a mess. Oh yeah, this is it. So all I have to do is drag this in, and bam, there's my color gradients. So not that difficult to create that color gradient map. There's not a lot of, it's hard to kind of see this range of green, so I'll just change this to something a little bit more different. So you can actually see there's where the actual high point, low point, and our site is kind of sitting in that middle range, right? So nothing real significant. But what's good about this is I've already kind of set the stage for analyzing the slope. So we can do that real quick. I bet you we can do that in the next 5 minutes. So this is what's great too, is that as you construct one of these, you can usually start to extract the other information. So the other great thing that's coming out of this mesh is the normals. So another way of saying vectors or direction. So basically whatever that face direction, it's giving a actual vector associated. Let me show you what that looks like real quick. So again, this is a way to visualize it first. This isn't actually part of it, but it kind of gives you an idea of what it looks like. So direction, so that's where I can kind of compare. It's probably going to look like a bunch of hairs growing off of this. Oh, it's actually going. So you'll see that they're actually going in the opposite direction, which is also something we want to fix. So I can always just utility, but it's good to know because that is going to affect it. Vector, reverse, and I'll just expand these a little bit more so we can see them better. So in other words, this is showing you what that relationship is of all those faces, the more or less what that perpendicular direction is. And this is what gives us slope. So in order to actually measure what that slope is, we have to compare that to a vertical line. So I'm going to get rid of those two guys. Now I can actually start to measure. So I can use this of all these different faces and measure it with a Z direction. Now I can still say within here, and now I can actually find the angle between these two, A and B. It gives me radians, which I have no idea how that correlates with slope. And it also gives you, you can always convert it to be, or you can convert it to be in degrees as well. But the way to convert radians into slope percentage is actually pretty easily. I can go to Math, Trig, and use the tangent component. So this is a way of essentially taking a radian or a degree and converting it into slope. So this has now converted it into slope in a decimal format. So instead of it being 50%, it reads 0.5. So I'm just going to go ahead and multiply that value by 100. I know that's where I'm kind of speeding up, but luckily it's going to be recorded. So now I've got it in slope percentage. What's great about this is now I can do the same kind of thing for this. So instead of looking at z values for the height, now I'm looking at the slope percentage, which is coming out of this guy. So I can just replace all of these units. I think that's it. So you can see that it's pretty much reading the way it should, right? So the green is where it's flat. That looks pretty correct. Versus here's those slopes. You can even start to see, let's try to look at this in rendered as well. Oops, maybe not. Well, it's actually, what's great about this, I can actually bake this and it'll have the color. I think it does. Don't correct me. I think you have to look at it shaded, maybe? Maybe not. Oh, all right. Anyways, we'll just look at it like this. Maybe that's why I got it deleted. So if I look at it in top view, you can literally see where some of these drainage areas are, which is kind of interesting. You can see exactly where that slope is of the site. So your site isn't really that interesting, so to speak, but you can start to see where that kind of sloped area starts to occur based off of this yellow. So yellow is at 50%, which tells you that the slope is at 50% or 45 degrees, which is nice. So this, you can even start to give it, start to control or understand it, right? So we know 50% is yellow. If I want to say that, you know what, like every time, because 50% slope, when it comes to a lot of different things, has a different relative impact. So usually plants like to grow anywhere between 0 to 40, maybe 30 degrees or 30%, or if you're lucky, 45%. Versus once it starts to exceed that, you can see, let's just put the red at 50 degrees. So now we know, or 50%. So now we know areas that are not conducive for planting, right? So we'd have to physically manipulate them in order to get that proper slope percentage. So you can see now through this kind of our influence of the topography and how it might affect planters. So with this, start to play around with these two parts of the topography script. So you can see it's not even that real complex. Wednesday, we'll start to look at some other things with the topography, as well as drainage lines. Something I recommend to download would be another kind of plugin for this. What's that? No. No. It should be Sonic, which is somewhere, or Sonic or Mosquito. Here we go. So it's referred to as Mosquito, but the ones we'll be using is this flow, which is part of. So this way will give us our drainage lines. Okay, so download that and have that ready for next week.